Hey guys, welcome back. Mr. Marone here. We are in 11.2, which is a whole section on area of what are known as composite figures, or these kind of odd looking shapes that we don't have formulas for. So we have to use a little bit of a process to solve these. And simply put, a composite figure is a figure that can be broken into parts. And those parts are going to be things that we know formulas for. Triangles, circles, rectangles, parallelograms, trapezoids, so on and so forth. And the process to finding the area of each composite figure is to divide up the regions and then find each area, and then you add them up to find the total area. So we're going to divide the figure into things that we know how to solve, and then once we found each part, we just add them up. We just find the sum. So perfect example is this first one here. So I've got two figures. I always number them. So I've got a rectangle and I've got a trapezoid. And what I'm going to do real quick is a little bit of arithmetic. So I know that I have 23 here. So a rectangle has the same sides opposite each other. So this is also a 23. Which is one of the bases for my trapezoid. And then if you look closely, the height of this rectangle is 12, and the total height they gave us is 18. So that means this height of my trapezoid is going to be 6. Okay, so I'm actually going to change the color of my numbering the figures for you here. So there's figure 1, and there's figure 2. So the area of figure 1 is the area of a rectangle, which is length times width. And the area of figure 2 is a trapezoid, so it's 1/2 your height times base 1 plus base 2. So if I'm solving my rectangle here, it's just going to be 12 times 23. And you're just going to multiply those. And so I have 276 over here. In my figure 2, in my trapezoid, I've got 1/2 times the height of 6, and then my bases are 23 plus 15. Half of 6 is going to give me 3, and 23 plus 15 is going to give me 38. And I'm going to multiply those, and I have my area of this figure is 114. So my total is going to be the 276 plus the 114, and you get your area is 390 centimeters squared, your total area there. So it's really just breaking the figure into things you know how to solve, solving them, and then adding it all back up. So looking at 2 and 3, I'm going to break the figures up for you. So I've got figure 1, figure 2, and figure 3. And then in figure 3 here, it looks like I've got figure 1, figure 2, and figure 3 right there. So we're going to step through this. In figure 2, I have what looks like a semicircle, or half of a circle, and then over here I have another half of a circle. So I've really got 1 and 3 together makes one whole circle. And if we look closely, they've told us that the radius of that circle is 6. So my area of a circle is pi times radius squared, and they told me that the radius was 6. So it's just pi times 6 squared. If you wanted to do each of them separately, you could do half of pi 6 squared and half of pi 6 squared, but it's going to get you the same thing. And 6 squared is 36, so 36 pi gives me 113.09 as my area, or 36 pi. You can use either one. It depends on the question. If they ask you to leave things in terms of pi or get exact answers, you'd use pi. Otherwise, you're going to use the decimal approximation. My second figure is a parallelogram. So I'm going to do my area equals my base times my height. My base is 5, and my height is 6. So the area simply is 30. Now, for our total, you really have two options. You have exact and you have approximate. In exact, that's where you'd use pi. So your exact answer would be 30 plus 36 pi inches squared. It looks strange, but that's an exact answer because we left it in terms of pi. If you're doing approximate, you would do 113.09 plus 36, or plus 30, sorry. And so you'd end up with 143.09. And that's, once again, inches squared. So it depends on the situation. It's good to have both. You can easily do both. It's not a very difficult thing to have an exact or an approximate answer, but just want to keep that there. I want you guys to try number 3 on your own. See if you can figure out all that's going on in here. See if you can find what measures you need in order to solve this out. I will tell you that you've got a semicircle, you've got a right triangle, and you've got a rectangle to solve. So you've really got 3 to solve. And when you come back in, those will be solved for you. All right, welcome back in. So I got my final answer as 325.23 square feet. And here's how I got that. I'm going to clear out this picture so that you can see what I did. So first things first, if my width up here is 9, that means that can also come down here, and that also comes here. So that serves as my radius of my circle, and since I have a radius in both directions, they're both 9. That also serves as the base of my right triangle. So that's how I was able to solve for my area of my semicircle. I was able to find half of pi r squared. Now, the other place we can draw a radius is straight up and down, and that accounts for part of this 26. So if this is 9, if I do 26 minus 9, that's going to give me this section here. So that's going to give me 17 when I subtract that. And if I've already accounted for 7 feet of that on the left-hand side, that means that this side is 10. So I've now got my base and my height for my triangle, and I've got my length and my width for my rectangle. And I was able to just plug in and solve and add them up. These take a little bit of time to get used to because you're trying to break them into figures that make sense for you. Some of these can be broken in multiple different ways, so there's not just one way to break them up. Just kind of keep that in mind as you're going through these. Make sure to bring in any questions you have into class tomorrow, and I will see you then. Have a great day, guys. Bye-bye.